Rational functions have a ratio look, where you have a polynomial in the numerator and a polynomial in the denominator. Rational functions, here's a graph, here's the equation that produced it. They also have something special. They have vertical asymptotes and horizontal asymptotes. Those are those broken lines you see. Now those broken lines are broken because they're not part of the graph, but they help us graph rational functions. An asymptote is a line that the graph approaches. Here's an example of a rational function. We're going to go and find the vertical asymptote. And you do that by setting the denominator equal to 0 and then solving for the x. So this vertical asymptote, the equation for this vertical asymptote is x equal -2, which is this broken line at the -2 mark. We need some terms for the horizontal asymptote so we can work with it. And these are the terms we need to learn. If you take the numerator polynomial, the leading term would be the term that carries a degree. The degree is the highest power on the variable. So 3x is the leading term for the top polynomial. 2x is the leading term for the bottom polynomial. Now that you've identified the leading terms, identify their degree. The degree is the power, the highest power on the variable. So both of them have a degree of 1. Once the degree of the numerator and the degree of the denominator are identified, compare them. If the numerator degree is less than the denominator degree, then our horizontal asymptote is y equals 0. If the degree of the numerator equals the degree of the denominator, then the y is made up of the coefficients of the leading terms. The coefficient of the numerator leading term, the coefficient of the leading term denominator. And if the numerator degree is greater than the denominator degree, then we don't have a horizontal asymptote. Here's an example. This is the top polynomial, the 1, and this is the bottom polynomial, the numerator polynomial, the denominator polynomial. Take the leading terms. So 1 is the leading term for the numerator, x is the leading term for the denominator. The degree of the numerator is 0, the degree of the denominator is 1. Compare them. The numerator degree is less than the denominator degree, so our horizontal asymptote is y equals 0. Here's another rational function. Identify the leading terms, identify their degrees, compare their degrees, and since the numerator degree equals the denominator degree, then the coefficients of the leading terms, which would be 3 and 1, together become y equal 3. They become what is going to be the horizontal asymptote. So the horizontal asymptote for this rational function is y equal 3. Here's another rational function. Take the leading term of the numerator, take the leading term of the denominator, identify their degrees, compare their degrees. Since the numerator degree is greater than the denominator degree, there is no horizontal asymptote. Now that we know how to find them, we go ahead and graph the rational function. You graph it like any other one, but these will have those extra steps of finding the vertical and the horizontal asymptote. So let's find the vertical asymptote. You set the denominator equal to 0, solve for x, and this will be x equal -2, the vertical asymptote for this function. Now get the leading term of the numerator, leading term of the denominator, identify their degrees, compare them, and they're equal. So when the degrees are equal, you take these front numbers and create the horizontal asymptote. Notice you could just think of the x's being canceled out. So y equal 3/2 is a horizontal asymptote for this rational function. Now you do what you would do with any other graph. You plot some points. Since you're dealing with asymptotes, the recommendation is you plot some points near the asymptote, the vertical asymptote. 2 on the left, 2 on the right. You'll see how that helps us. And you pick some numbers that are close to the asymptote on either side. So here are the points, the x's that are close by the vertical asymptote. Let x equal -3, x equal -4, x equal -1, x equals 0. Then plug them in one by one into the rational function, the one that was given at the beginning. Solve for y. Y turns out to be 3.5. If you let x equal -4, y becomes 2.5. And if you let x equal -1, y is going to be -0.5. And finally, if you let the x equal 0, y will be 0.5. So these are the points that we've collected. These are the x's we're inputting right now, and they're partner-wise. Now notice these two are these 2 points. Since we know that the curve is going to draw closer to the asymptotes, once you put these 2 points, you draw it such that the curve gets close to each of these asymptotes. And then plot these 2 points, and then you know that the graph's tendency is to get close to the asymptote. So you draw these, and now you could draw these curvy because you know they're trying to get close to the asymptote. This graph is the graph of the rational function.